Hello, I'm Reba. Right now we're going to be working on the absorption spectrum of chlorophyll experiment, which starts on page 94. The instructions finish on page 95 of your lab manual, and then your data recording will happen on page 99. So in the chromatography experiment that you've done, we got bands for chlorophyll A and chlorophyll B that came up that chromatography paper. All I've done is I've carefully cut those out, and I've put them into these beakers with a little bit of acetone. You might be able to see that that liquid is changing colors because the pigments are being dissolved in that acetone. That means now that we have a dissolved pigment, we can use a spectrophotometer to measure which wavelengths of light are being absorbed and which wavelengths of light are not being absorbed by our chlorophyll pigments. Now is a great time to try to think back to your lecture about which light spectra are absorbed and used for photosynthesis and which are reflected and not used for photosynthesis. That'll be the basis for a great hypothesis about what we're going to find when we use our spectrophotometer. So I'm going to start with the chlorophyll A. I'm going to pour that pigment into this cuvette, which is a see-through glass tube. We're going to shine light through that glass tube, see how much of the light comes out on the other side. If not a lot comes out on the other side, it was absorbed. If a lot of it comes out on the other side, it was transmitted, not absorbed. It's important to have a control, so we're going to use just the solvent without any pigment in it in the other cuvette. And I'm going to try to make it about the same volume here. Oops. Got a little extra. Okay, great. So we're going to start at 340 nanometers. I'm just going to show you a couple of these, and then we're actually just going to give you the data when we're done. So I'm going to put my control into the light reader, and I'm going to zero it out by pushing that button. Oh wait, we need the absorption, that's why. I was on transmitted, so we're saying 100% of the light was transmitted, but we want to know how much was absorbed. 0 absorption, that's what I want to see. Okay, great. So we'll take that control tube out. We'll put our chlorophyll A in there, and we'll see how much of the 340 nanometer wavelength is absorbed. We got 0.14, so I would record that here. What we would then do is repeat that for all of our wavelengths. So I'm going to change this to 360. I'm going to measure how much light is absorbed in our control, zero it out. And then we will see what's true for our chlorophyll A pigment. This time we got 0.18. We are going to continue this experiment without you watching me for the rest of the time, and we're just going to give you the data for both chlorophyll A, which is what we've been looking at so far, and then we'll repeat all the same wavelengths for chlorophyll B. Aren't you feeling lucky you're not in lab doing this yourself?